Hello guys, with this video we're going to review how to add and subtract mixed numbers and fractions without having to transform them into improper fractions. Alright, so first step, rewrite fractions using the LCD if necessary. Second step, we will add or subtract the fraction parts, and then we will add or subtract the whole parts, and finally we will put all the pieces together and see if we can simplify. So if you notice in this first example, we don't need to transform anything using the LCD simply because these two fractions are the same. So let's simply add the whole parts together, 3 plus 2 together, okay, plus the fraction parts together. Because they have the same denominator, this is a piece of cake. This will be simply 1 plus 5, right? These are these two numerators that I'm placing together here. So then, final result will be simply 3 plus 2, that's 5, that's a whole part, and then the fraction part is simply 6/8. So the last step here is simply simplify this. So this is going to be 5 and 3/4. So first example, easier than peeling off mandarins. This method also works with subtraction. Okay, in this case, again, we do not need to transform any fractions using the LCD, right? So we will group together, we will associate here the whole parts. It'll be 5 minus 4, okay? And then we must add the results of subtracting 2/8, right, from 5/8. Here we go, it's the same denominator. So all I'm doing is putting these numerators together here, right? 5 and 2 are the numerators over the same denominators. So what is going to be the result here? 5 minus 4, it's just 1. And the result of the fractions is going to be 5 minus 2, that is 3/8. Okay? So the final answer here has to be 1 and 3/8. So there you go. This is the result. Easy and fast without transforming the fractions into improper fractions. Okay, this third example requires us to first then rewrite fractions using the LCD. So we will copy them, right? This is 3. Okay, what is going to be the LCD between 4 and 5? It's 20, isn't it? So, how do we find the new numerators? Find an equivalent fractions, remember? So it's going to be 20 divided by 4, that's 5, and then 5 times 3, it'll be 15. Okay, then we repeat the process with the next. So 20 divided by 5, it'll be 4, and 4 times 4 is 16. So now, the first step has been done. So then we proceed as before. 6 and 3, we can join these two together, the whole parts, and it's going to be 9. Okay, we can do that automatically. And then the fraction parts is going to be the same, of course, same denominator here, and we can add the numerators. That's going to be what? 15 and 16 together. That's 31. Okay, so what happens here, if you notice, is that this is an improper fraction. So we need to transform it quickly into a mixed number. Okay, so the whole process will be 9, this is 9 whole parts, and 31/20 is actually 1 because 20 goes into 31 only once, right? And 11 is the numerator because that's the difference. So we're almost done. 9 plus 1, that's simply 10, and the fraction is 11 over 20, and that's that. Okay, in this next example, even though we have the same denominators, if you notice, the second fraction is 5/6 is bigger than 1/6. So in order for us to solve this one, we must first rename the first fraction the following way. We borrow 1 from the whole part, so that becomes 3 minus 1, it'll be simply 2. We copy the same denominator, and the new numerator will be the sum of the numerator and the denominator. 1 plus 6, 7. So we will take these new approach. This is the first fraction that has been renamed, and by the way, I'm not changing the amount, okay? Because if you notice and use your imagination, this is like having 3 complete pizzas and 1 6, and all I'm basically doing is making cuts of one of these pizzas, right? I'm making exactly 6 cuts, so 6 slices. So I still have 3 and 1 6 if you notice, but now I'm just writing it down differently. Now I have 2 complete, that's 1 and 2 complete pizzas plus 7 6, because I have 7 slices. Notice we have here 6 slices plus 1, right? So this is what I'm basically doing. So all I need now to do is to copy this new renamed fraction. So it's 2 and 7 6 minus 1 and 5 6. So now this is easy, right? Now we take care of the whole parts. That's 2 minus 1. That's going to be what? Just 1. And the fraction part, it'll be the same denominator and simply subtract now. That is going to be 7 minus 5. That's simply 2. So once this mixed number is simplified, is dividing both by 2, it's 1 and 1/3. So this is the final answer. So one more time, how do we rename? So let's say we have to rename 4 and 3/7. So to rename a mixed number, we must borrow 1 from the whole part. So 4 minus 1, it's just 3. That's to begin with. Then look at this. It's going to be exactly the same denominator. So this is pretty easy. We write 7 here. But the numerator, look at this, is going to be the sum of the old numerator, which is 3, and then we add 7. We add these two together, and that's going to be simply 10, right? So 4 and 3/7 is the same thing as 3 and 10/7. Okay, so let's now proceed. Okay, we're going to solve the last 2 examples the following way. 4 and 1/4 minus 1 and 1/3. They have different denominators, so we have to rewrite these same mixed numbers but with the LCD, correct? So what is the LCD between 4 and 3? It'll be simply 12, isn't it? So we just copy 12 as the LCD, and we will simply go ahead and first divide and then multiply, right? So we do, okay, 12 divided by 4, that simply will be just 3, and 3 times 1 is just 3. And then we do with the next the same thing, so we do 12 divided by 3, that's going to be 4 times 1 is 4. So here, what's going to be the final result? 4 minus 1. However, if you notice, 4/12 is just bigger, slightly bigger than 3/12. So we have to rename the first fraction, the first mixed number. And we already know how to do this. We borrow 1 from these 4, which is now 3. We just copy 3. We copy the same denominator, and we simply add 3 and 12 together. Okay, so that's going to be 15. And now we're going to be able to do it very easily here. Okay, so what's 3 minus 1? You know, the whole part's here. It's going to be 3 minus 1. It'll be simply 2. Okay, we have the same denominator here, and the numerator will simply be 15 minus 4. That is 11. So as you can see, we can solve these problems very easily by renaming when it's necessary. By the way, we only rename when we are subtracting and exclusively when the second fraction is just larger than the first. Okay, to solve the last example, here we must rename because we have no choice. If you notice, 3 minus 1 and 3/4. And how do we do this? Same thing. We borrow 1 from 3. It'll be just 2. And the fraction will simply be 4. Why 4? Because it's the same denominator as the second one, right? So 2 and 4/4, it'll be, you know, just like 3 original pizzas. And all we are doing one more time is just cutting the third pizza into fourth. So that way we just rename, it's the same amount, 2 and 4/4. Okay, so now that we're going to be able to do this very easily, that's going to be what? Whole parts 2 minus 1 is just 1. And here the denominators is the same, so the numerators will be 4 minus 3, it'll be just 1. This is the final answer. Well, that's all, folks. I hope you enjoyed it.